Hey everybody, we're going to do a lab today. Now, during e-learning, it's going to be pretty challenging to do labs. I can't expect you guys to have all the equipment at home. So what I'm going to do is I've got some equipment here, and I'm actually going to do the lab, and then you guys are going to take the data down and do a little mini write-up and submit that. Okay, so today's lab, we're going to measure the speed of light. Now, I know speed is distance divided by time. So all I need is a distance and a time, and then I can get the speed that way, or we can get the speed that way. Okay, so I'm standing by the light switch here. What I'm going to do is I'm going to flip that switch on, and then I'm going to start the timer, and then as soon as I see the light, I'm going to stop the timer. And then afterwards, I can measure the distance and then get you guys that data. Okay, so I know light is pretty fast, so I'm going to pick the light farthest away to help me out a little bit. Okay, so here we go. Okay, that was pretty quick. All right, let me try that again. Okay, this isn't going to work. All right, one thing I've learned in life is to never give up. So that last experiment trying to measure the speed of light did not work. So I didn't want to give up. I was talking to my daughters about this, and they reminded me about electromagnetic waves and that they all travel the same speed. They just have different frequencies and different wavelengths. So light is an electromagnetic wave, so they said if we can look at a different type or a different category of electromagnetic wave, maybe we could figure out the speed there. So we're thinking about things around the house, and microwave oven, that uses electromagnetic waves, the microwaves. So we thought, well, let's try to do that. We're also going to use this chocolate bar because microwave ovens work off the concept of standing waves. Remember standing waves? It sends a wave out, gets reflected back on itself, and if it perfectly lines up, just the right frequency, you'll get a standing wave. So yes, microwave ovens are designed to be a specific dimension inside of it to create those standing waves. Okay, to get the frequency of the microwave, there should be a label somewhere, and ours is right up there. Okay, so it says 1.5 kilowatts, 60 hertz. That's not what we want, that's the input. The output, 1100 watts at 2,450 megahertz. 2,450 megahertz. So that would be 2.45 gigahertz is our frequency. Okay, we've got the chocolate bar in there. And if you notice, I took the turntable out. We do not want this to rotate. So let's close it up. Let's punch in about 20 seconds and watch it go. There it is. All right, so we got the chocolate out of the microwave, and it didn't look melted, but we poked around a little bit and found melted spots. So here's a melted spot right here, and then there's a melted spot right there. So we need to measure the distance between those two. So I'm at home. I don't have a metric ruler at home, although I should. So I have a tape measure. We're going to measure this in inches. So if I hold this up here, it's about, it's about 2.5 inches. Okay, you're not going to be able to see that anymore. So let's call that 2.5 inches. All right. Now, what does that mean? Remember, we're dealing with standing waves here. So we've got nodes and antinodes in standing waves. Nodes are points of no deflection. In other words, the incident wave and the reflected wave cancel each other out at that node. The antinode is where they really build on each other and you get a big amplitude there. So if you look at the melted spots in the chocolate, that took energy to melt those spots. Those must have been antinodes. And then directly in between those two antinodes would be a node. So there you have it. The distance between two antinodes is, let's call that 2.5 inches. So you'll need to convert that to meters. And I highly encourage you to draw a picture of a standing wave. Mark 2 consecutive antinodes. Think about how many wavelengths are from one antinode to the very next antinode, and then work with that accordingly. Okay, the frequency again, 2,450 megahertz, so 2.45 gigahertz. And from that, you should be able to calculate the speed of the microwave, which is the speed of light. So now we have a partially melted piece of chocolate. What are we going to do with that?
Oh, mine's already Science is delicious.